Good morning and welcome to my presentation on R Shiny modules. Today we're going to take a very basic example, break it down into modules and show you how you can build up an application just using modules. This will help in your future build more complex Shiny applications and bring greater flexibility to those. For the following example, you will need to install the following packages: Shiny, Shiny Dashboard and Shiny Widgets. For more information from RStudio, please follow the link on the slide. Many people might ask, why do we need to use a module? As quoted from RStudio, as Shiny applications grow larger and more complicated, we can use modules to manage the growing complexity of a Shiny application. Using modules allows for both user interface and server code to be reused many times without the worry of the problems around namespaces. As many of you already know, using the same namespace over again in a user interface will cause an error within the code and will not allow for the user interface to load properly. So let's start with our old faithful example. When we start to build a module, it is made up of a user interface section and a server section. They both act in a similar way that you might find a function. As I mentioned earlier, the namespace needs to be kept different for each individual user interface element. In order to achieve this, we use the function ns. ns is wrapped around the input IDs in order to keep the unique namespace. The namespace will append the module ID to the input ID. For example, if we had module ID as 1 and the plot displot, this will become 1-displot. One thing to note about modules is that the module server can contain many different elements. These could be rendering outputs, observe events, reactives, etc. As long as the variable is entered into the function of the module server, we can utilize it anywhere within the server code. Let's take a look at an example. Within this particular example, we're going to start with 4 files: the UI and server, as usual, global, and then our modules file where we will keep our modules source code. Within global, we need to call our modules code, so we are going to source modules.r. When we set up the user interface side of this, we're now going to call whatever we have called the module, in our case module_UI, and then the ID code of the module that we're looking at. As you can see, we're going to call this twice. The same module is going to be utilised, but with an ID code of 1 and then 2. This will show how the replication can be utilised, and those module IDs will keep our namespaces separate. We then need to set up the server side of things. As you can see, we're going to call the module twice, again with the ID codes 1 and then 2. We're going to pass the data set that we want to use. In this case, we're still using the faithful data. First, we're going to use column 2 and the weighting information, and secondly, column 1 with the title of eruptions. In this particular example, you can see that I've used a variable ID2, which is the same as ID. If you are using a newer version of Shiny, this is not necessary, as the ID code is easily accessible within the module server function. In older versions, you can also utilize session $ID in order to get the ID code. But for simplistic reasons today, we are going to stick with the ID2 variable being the same as the ID, so that we can call it and see exactly what we're utilizing. Now, this is what we saw right at the beginning. This is our modules file. At the top, we have module_UI. This contains our user interface code and can utilize any parts of a user interface, such as fluid row, box, UI output, plot output, etc. The outputs that we are calling are going to be ones that we set up within our module server. Therefore, we are wrapping them with that NS notation. This allows for that module ID to be appended to the input ID. So, where we have slider as our input ID for the UI output, this means that will now become 1-slider or 2-slider, depending on which call module it is inside. On the second half of our module file, you'll see the module server. Again, this is set up very similar to a function. We always have our input, output, session, and then whichever variables we would like to pass into the server function. In this particular example, we have a render UI for the slider input, a render plot for the histogram, and a render text which will allow for a title name. In order to keep our namespace IDs the same, we also need to include the NS ID. This is why I've used the ID 2 so that I can quickly and easily replicate this namespace. As I mentioned earlier, there are other methods of doing this, such as using session $ID in order to get the ID of the server module. One thing to note is that unfortunately I have a slightly older version of Shiny on my machine. If you are using a Shiny version of greater than 1.5, the syntax was slightly altered. This won't make too much difference as the older syntax will still work, but it is something to note. On placing all of these elements together, this is the output we will see when we run our application. We have the top half, which is our module UI1, which also utilises the call module of the ID code 1. These two will now talk to each other. As you move the slider, the histogram will still update. The second plot below has the module UI with the ID of 2 and utilises the call module for the module server with the ID of 2. Again, these two will talk to each other, but there will be no overlap between the top and the bottom plots. So as I just mentioned, as long as the IDs are the same, inputs can talk to each other, modules can talk to each other. So this means that we can have various modules that all interact with each other. The IDs must remain the same between the modules that we are calling in order for them to talk. If we wish to reference a different input with the same ID, we do not need to use the namespace notation. When working in the module server, we can simply call input $input ID without the need of the namespace, as long as those module IDs are the same. Let's go ahead and split our example so that we have a slider and chart, which are a module each. This is now our slider module. At the top of it, we have our slider UI with our namespace notation, and we just keep the UI output with slider. We then have our slider server. Our slider server contains the render UI where we have our slider input that we are setting. We now need a separate module for our plot. So we have our plot UI at the top with plot output displot wrapped in the namespace. Then we have our plot server, which includes our render plot, and our histogram is being built in here. You can see on line 20 where I have placed the require input $bins that I've not used namesake, and this is what I was alluding to earlier. As long as our namespaces are the same, we do not need to call the namespace notation. In order to keep our UI file as clean as possible, we're actually going to put these together now in a third module. I'm calling this module's title, and will include the render text for the title name in this particular module. The top module UI still calls the UI output slider plot output distance plot, and also the title that we are rendering below. As you can see, this means that our UI section of our code doesn't change compared with the example that we had before. Our server code we now need to call each module separately. So for each ID, we need a call module for slider server, call module for plot server, and call module for title server in order to put them together. We replicate this for ID 1 and ID 2, keeping those datasets and title names different depending on what we want to utilise in that particular section. Since we have added additional files, we also need to remember to update global in order to call these into our application. Lines 2, 3 and 4 are just adding the additional modules that we are now utilising. This is now our output. As you can see, it's exactly the same as what we had before. So you might be asking yourself, this code is more complex. Why would we do this? By splitting it, we're allowing ourselves for greater flexibility. For example, what if we wanted one as a slider and one as a knob input? Shall we take a look at this? So we're going to add one more file called modules_knob. For this, we actually only need the knob server section. We're still going to call our output from the render UI slider. This means that when output UI is called, it's the same name. It doesn't actually matter that this is now a knob input instead of a slider. It will still place it in the UI in exactly the same way. Going back to our server file, if we now want to change the first plot to have a knob instead of a slider, we can do that by updating the server that is called. As you can see on line 21, we now call the knob server, but keep the ID and everything else the same. For ID 2, we're going to keep the slider server. You can now see in the user interface above that we have a knob at the top and a slider at the second one. So let's expand this a little bit further. What if we have 10 charts we want to show, or 10 tabs? They all have different data, and you need to decide whether you want a slider or a knob for each individual one. Now, this might sound like it's going to be a lot of call module lines, yes? This is where a configuration file and lapply come into their own. In this example, I'm going to force a configuration file to be our chart list. This is a data frame. We have our ID codes, our dataset column that we want to use, the input type that we want, and then the title. We then want to know how many times we want to go down our chart list. How many rows does it have? This is wrapped into the observe. We can then use an lapply to go down and through the configuration file. This means that for each call module, we're going to tell it what type of input type we want, using the get as character and input type looking at that particular chart list for each line. So i.e. the first one will be 1, second one will be 2. The second and third parts are always going to be the same server for the time being, so we can just call them plot server and title server. The ID, the dataset and the title name will change depending on where we are going through that list. So now you can see that using that configuration file and wrapping the lapply, we can now have exactly the same output as what we had before, but utilising a lot less code. This means that we could have 10 lines in our configuration file, each producing a different plot with different information and potentially having a different section of UI included. We could have this as a number of tabs, a number of boxes. You get the idea. This would grow very quickly and be highly customizable. But wait, we haven't updated the UI side. At the moment, our UI is only looking for the IDs 1 and 2. So we need to update this so that it also produces the UI side for as many lines as we have in the configuration file. This is where we're going to utilize UI output. This means that we can render the UI within the server code and then just place it within the dashboard body as UI plots. So we now need to render our UI. We're going to use the same nrow going down the chart list and an lapply. For each row, we're going to look for the ID and then call the module user interface based on the ID that we have in our chart list. This means that we can now grow our user interface, and for every line in our configuration file, we'll now have a chart and slider or knob and the correct title. I hope you've learnt a lot from today. Here's a few summary notes. Now we have it set up, it doesn't matter how many plots we want to show. As long as they're in our configuration file, we can reproduce them. Also, remember that modules can include any UI elements, boxes, drop-downs, text input, etc. One thing to also remember is that tab set panel is a slightly special case if you want to use it within an lapply. You need to produce the tabs and then use a do call for tab set panel and pull in the tabs. There's an example within Stack Overflow here. Thank you so much for spending your time to listen to this presentation. I hope you've enjoyed it, and please let me know if you have any questions. Please like or subscribe to my channel. Thank you.